In section 6 we probably learn in some ways the most challenging derivative rule called the chain rule. It's challenging when you first get into it, and then I think it will get much easier. The chain rule, just to kind of summarize what you see on this slide, the chain rule basically deals with composite functions. How do you take derivatives of composite functions? So in the first function that you see here, we actually have a square root function, and inside of it we have x squared plus 1. And so if we were to define function f as square root and function g as x squared plus 1, I can now write the original as f of g of x. And the chain rule will tell us how to differentiate that. We have not run into that issue before. And basically what it runs down to, I mean, you can read through all of this if you want to. The best way of explaining it is probably the stuff that's down here. Okay, you are going to first of all take the derivative of just the outside function, and you leave the inside function in there. Just treat it as the x that would normally be there, and then at the end you multiply by the derivative of that inside function. Lots of ways to talk through that. We're just going to run through a couple of examples, and then if there are other questions, we'll discuss it more in class. So in these examples, the first three examples, all of them we're going to take derivatives using the chain rule, but there are other ways to do this. So for example, part A, I can just use the quotient rule, and it might be easier to do with that initially, but there is going to be a way to do this using the chain rule. And the first thing we're going to do is rewrite it. This function is actually equal to 2 times, and then we bring the 3x plus 1 up to the top, and we raise it all to the negative 1 power. So the way I want you to picture this now, 2 is just a coefficient. This is really the chain rule part that we have to work with. X to the negative 1 power is the outside function, 3x plus 1 is the inside function. And so our rule says take the derivative of the outside function first. So you don't necessarily need to write this down, but if we were to take the derivative as our original problem of this, you'd say, oh, I bring the negative 1 down, rewrite the x, and then it's going to be raised to a power 1 less. And so we're going to start out by doing the same thing. We're going to say that f prime of x, remember the 2 is just a coefficient, so we rewrite that again. And then to start the derivative process, I take that negative 1, move it down to the front. I'm going to rewrite the same base, so 3x plus 1. That's kind of like just the normal x that we had here. We just rewrote the original base. The power is going to go down by 1, so it's going to be negative 2. And so in your notes that was take the derivative of the outside function, leave the inside function alone. And then in our notes it said at the end multiply by the derivative of the inside function. So what's the derivative of 3x plus 1? That derivative is simply the number 3. And so this is one that we're going to take a little bit of time to clean up, just because you're normally not going to leave an answer like this, or for multiple choice it won't be written like that. The coefficients that I can combine would be a 2 times a negative 1 times a 3, so that gets me a negative 6. And then we have 3x plus 1 to the negative 2 power, and if I really wanted to, I could rewrite that as negative 6 on top. 3x plus 1 squared in the denominator, and that would be my first and probably my first answer, probably the best answer for this particular case. Our second example is going to be very similar to the first. That's already written with the power. We're looking at x squared plus 2, all of that being cubed. The way to do this without using the chain rule would be to actually distribute the third power, to go x squared plus 2 times x squared plus 2 times x squared plus 2. That would take a long time to simplify and distribute all that, so in this case the chain rule is going to be the best option, I think. And so we'd start out by saying g prime of x. Our outside function we could think of as being x cubed, so we're going to take the derivative of that just kind of quickly here, and that would be 3x squared in the end. That's hopefully kind of an obvious thing by now. Now with the chain rule, we are bringing the power of 3 down. we're rewriting the original inside function that was kind of our original base. That original power goes down by 1, and then at the end we multiply by the derivative of the inside function. The derivative of x squared plus 2 is 2x. And again, I'm going to simplify a few things here, not as messy this time, but just to get in the habit, we'd have 6x times x squared plus 2, and just that last part is being squared. So this would be a good final answer. The last one's sine of 2x. The way you would take the derivative of this, you'd have to use some trig identities from pre-calculus, so that would not be a good option for us right now. So to start out by finding h prime of x, our outside function here. Oh, that was gross all of a sudden. Let's see if I can erase any of that. Good. Okay, h prime of x, the outside function is going to be sine, inside function is 2x. And so if we're going to take the derivative of the outside, derivative of sine of x, we know by now is cosine of x. So I would have derivative of the outside is cosine, be cosine of x, but we're going to leave the original in there, so it'll be 2x. And then take the derivative of the inside function, the derivative of 2x is 2, so just times the 2 at the end. I do want to rewrite this one because I want to be clear that it's cosine of just this, and then you multiply by 2. And otherwise we can get confused quite easily. So I am going to rewrite it as 2 times cosine of 2x, and that would be the best answer. So that was a very quick explanation of the chain rule. More just a few examples of how to do it. If you want more reasoning behind why it works, make sure you ask a question in class.